Our Smart Cruise Control project is done for our capstone project, part of our electrical engineering degree from Eastern Washington University here in spring 2013. The Smart Cruise Control provides an enhanced cruise control experience, enhanced beyond that readily available on the market today. The Smart Cruise Control will not only maintain a steady speed, but will also slow down if traffic requires, and will even slow to a complete stop and resume speed again as traffic permits.
I was sitting in traffic on Interstate 5. I kept doing stop and go over and over, and I came up with this idea of a cruise control that keeps not only the speed but also the distance automatically. And I talk about it to Peter, and he says, nice idea. And then we jumped into the project right away. So the first challenge was how to stop a car in various speeds. And we came to realize there are only two things we have to consider: the current speed and the acceleration of the front car. And those two elements are proportional to safe distance at which either acceleration or stopping process should begin.
One of the obstacles that we encountered when developing the Smart Cruise Control program was the braking system that came on the original RC car chassis wasn't adequate to provide safe braking without bumping into the lead car. We ended up disabling the braking system on the RC car and building a solenoid powered braking system for the Smart Cruise Control car. The solenoid system allowed us to have a much greater degree of control over the amount of power we applied to the brakes and the duration as well. So that gave us the flexibility to provide the right amount of braking for the situation. One of the obstacles that we encountered was the lead car had a much greater rate of acceleration than the Smart Cruise Control car, and as a result the lead car often got away from the Smart Cruise Control car. To resolve this, we replaced the drive system that came on the lead car with a microcontroller and a servo, and this allowed us to have much greater control over the acceleration rate as well as the steering. Additionally, it provided us the capability to download programs to the lead car that would contain routes, pre-programmed routes for the lead car to follow.
Okay. In the beginning, the computer picks up some other object like a wall, chairs, or people that is close to the system, and we limited the scanning area so that it can focus on more an object in front of it, and that worked fine for a while. And then another issue came up, that is, when object go left it was okay, but when it goes right it often misses the target. Problem was our scanning process goes left to right, and when object goes right, an object located on the right side of the area, it scans a whole bunch of unnecessary data over and over, and that caused the loss of target. So we changed it to go right to left when the object goes right. And there are a bunch of that kind of problem solving processing, and every corner we learned a lot and really enjoyed it.
We programmed 3 routes for the lead car that the Smart Cruise Control follows. The first route we programmed for the lead car to take simulates straight line traffic with stop and go conditions. The second route we programmed has the lead car driving in a circle. This requires the Smart Cruise Control car to track the lead car and to maintain that tracking and to follow it at a safe distance. The third route we programmed combines the elements of the first two routes. The third route has the lead car traveling in an S-curve, which requires the smart cruise control car to lock on to the lead car and to track it as the lead car repeatedly changes directions. Some areas for future development with the smart cruise control include integrating a moisture sensor to detect when roadways are wet, which would then trigger the use of another set of algorithms to make sure safe driving distances are maintained and braking is done safely and still maintains traction with the roadway. One potential area for future development is integration of an accelerometer. The additional data obtained from an accelerometer would allow the smart cruise control car to be aware of when it's going uphill and would require additional power to maintain a safe following distance behind the car it's following, or going downhill, possibly having a greater following distance to make sure that the additional braking distance necessary would be maintained. Finally, one potential area for future development on the smart cruise control car is integrating the ability to avoid obstacles that cut into traffic, such as a car darting in or even a child chasing a ball. Sam and I have enjoyed working collaboratively on the Smart Cruise Control project, and we've learned a lot through overcoming the obstacles we encountered during the course of this capstone project.